It's my privilege to welcome our next distinguished speaker, Dr. P. Naramari Sastry, Professor of ECE at CBIT, Hyderabad. With over 9 years of industry and 20 years of academic experience, Dr. Sastry is a passionate teacher, researcher, and innovator. He holds a PhD from JNTU Hyderabad, along with degrees in microwave engineering, marketing management, and an MBA in operations. He has guided multiple PhD scholars, filed and successfully granted a patent on palm leaf character recognition, and completed an AICTE funded research project on the same. With over 40 publications, including 8 in SCI journals and IEEE communications, he continues to blend traditional wisdom with modern technology in his research. It's an honor to have you here, sir. Welcome to the session.
Yes. Good afternoon, everybody. Am I audible to everybody?
Yes, sir.
Yes. Let me share the screen because the time is very short of 40 minutes. So let me share the screen. With all my industrial experience, I am presenting this session of more than 10 years, a decade. In the initial stages, I used to I used to work on predictive maintenance machines in the initial stages. Then in the year 2003, I have established an industry also in this area called MCM Instruments India Limited, India Private Limited. And I give my technical advice to the industry even though I am in academics. So with this background, am I audible and is my screen visible? Can anybody tell me? Am I audible and also the screen is visible, right?
Yes, sir. It's visible.
Yes. So the predictive maintenance of different machines is the topic what I have taken up for today. And I have worked in a company called Predict Technologies India Private Limited. Even today, the company is there 25 years back. I was the first person to get appointed into that company. And I was a machine analyst, worked as a machine analyst in the initial stage. And these instruments were purchased. And we had a collaboration with Predict Technologies, Cleveland, USA. And still today, the company flourishes and gives training to different people in Hyderabad. So from the industry, I came to the academics after a decade. And our main clients were like IOCL, IPCL, wherever there is a rotating equipment, like L&T Cement Plant. Awarpur was a very big client for us. Rajeshri Cement Works, L&T Tadipatri, these were the clients. So real time they use these things, and I was the main machine analyst there. So here, let me tell you what is my agenda. The examples of machine failure, what are the different types of maintenance systems, why preventive maintenance is so important, how the predictive maintenance came into the picture, and predictive maintenance, I remember in the year 1995, that is about 30 years back, it had come. That time we had only, we were using AI, but that special term of AI has come up nowadays, and we were using the same techniques. But nowadays we use the cloud computing and quantum computing, and cloud computing instead of the servers what we used to have in our laboratory those days. So today we use cloud computing and we speak about how the quantum computing helps us to compute. The technology is similar. Only thing is the speed in detection of the faults, has increased. So I will be talking about different maintenance types. Here you can see the products in the market like motor checker, bearing checker, vibration transducer, ferrography. Ferrography means study of ferrous particles, in the what is called that oil lubricant. So this was the ferrography helps us for the predictive maintenance systems. So let us go one by one. If you see in the next slide, I speak, there were some expensive machine fails, which we can see all of you must have heard in 2010. there was a deep water horizon oil spill. Because of that oil spill, people could not, the oil leakage, so people could not use their ship for crossing the oceans and sea near US, and there was a lot of business loss. Same way, if you see the mobile Samsung Galaxy Note, that a small battery, the small battery defect, you can see here, small battery defect caused a fire and $17 billion were damaged. Similarly, if you see, there was a blockage in the Suez Canal, and because of the ship, one of the largest containers in the world, the ship container, it blocked, and lot of the cost went to billions of dollars, revenue loss. Again, Apollo 13 mission, here the oxygen tank explosion, that caused, and everywhere the machine is giving trouble. And recently you must have seen the Ahmedabad, what is called that plane crash. We would have predicted, if the oil sample was taken and it was analyzed, we could have predicted the failure of the engine well in advance. But but we really feel bad that after the explosion, people took the oil sample and they are analyzing. Even today, they have not come out with the proper reason. What was the reason why the engine failed and all? So here, if you see the different types of maintenance systems, as I told, first one is preventive type, second one is predetermined type, third one is condition-based maintenance, fourth one is predictive, fifth one is corrective, sixth one is reactive. This reactive, what I was speaking, you can see here, I am showing with the cursor, the example. In the reactive maintenance system, they collect Air India Boeing 787-8 crash in Ahmedabad. They take the oil sample and do the analysis, and they react that what engine can be, how the engine can be improved further. But if you come back to the preventive maintenance system here, you can see you do it, you try to prevent. The name itself says preventive, means you try to prevent it by regular and periodic checks in the running of the machine. So the benefit is, see, regularly we go take our two-wheeler or four-wheeler for preventive maintenance. We take it to every year for our car to get serviced. We see that whether oil is to be changed, bearing is to be changed, gear is how much worn out. All this is preventive maintenance system. Now, example I told about our car. So, if you come to predetermined, it is followed in a factory. They have a schedule. They make a schedule and they predetermined way they go on checking the health of the machine, and it is predetermined. So it is very easy to schedule and manage. And you can hire technicians instead of maintenance persons. You can what is called example for this are large machines are maintained in factories. Again, coming to condition based maintenance system, where the condition of the machine indicates the maintenance needs to be performed. So downtime is less. What is downtime? Downtime means when the machine is put off and maintenance is done on it. So in the next coming slides, we will see fixed cost and variable cost. So the fixed costs are like salaries, like the electricity, what we use for the room rent, all factory rent and all these things. Whereas variable cost, if you see the number of hours what we use on the machine, it varies. So based on the production times, production schedules, it varies. So if you see here, condition-based maintenance, so a greater productivity, equipment runs in peak performance for longer time. So here you got sensors for the pumps, motors, and other things. So you measure the vibrations and all. So we will go in deep with the equipment what we manufacture. Then comes predictive technology. The predictive technology, I told you earlier also in 1995, it was brought to India by a company called SPM Instruments India Private Limited, Amirpet. So where I used to work. So it had a connection with Predict Technologies, Cleveland, Ohio, and we used to we used to take a oil sample just like the blood sample. We make a smear and the particles are identified and measured and the quantified with the purpose, with the machine analysis experience, and AI is used. Those days we used to use AI with respect to the servers what we had in our companies. Now it is global. We use the cloud computing and quantum computing for doing this predictive maintenance systems for process industries. Any industry where rotating equipment is there, we need predictive maintenance system. What is this corrective maintenance system then? It occurs to fix an issue or fault or failure or breakdown in an existing machine. So once we know there is a fault, suppose there is a lot of vibrations coming, we can solve the vibrations problem like we check for the foundations, we check for the bolts or nuts and bolts are proper or not. So we can correct the problem, root cause of the problem for the what is called that vibrations, and we can do the corrective maintenance. Reactive is after the incident has happened, like Ahmedabad case, we go and take the oil sample and find out, and we do the maintenance. We find out the cause for it, and we try to rectify it in future productions of the engines. So if you go to the next slide, I say here I told you there are fixed costs, there is variable cost. So fixed cost, as I told you, examples of the rent of the factory and salaries of the factory and all. Variable cost depends upon the raw material, how much we have purchased, how much raw material, how much time we have used the machine, how much manufactured product is how much product is manufactured and sold at what profit. This is all coming in. This all includes the variable cost. So when we do the maintenance, we have the fixed cost at its place, but the variable costs decrease, but profits also decrease. That is what I showed in this slide. So the next slide here, I speak about the predictive maintenance. Earlier, I told you, even in 1995, in the electronic industry, automotive industry, we use the sensors in the vehicle to collect the real-time data on various parameters of the engine, like how much wear and tear is there in the tires, how much wear and tear is in the engine, how is the lubrication condition, is the filter working, the filters which are there in the machine, whether they are working or not. One common thing I want to tell you all, my dear friends. So if you collect a oil sample before the filter and after the filter, you measure the wear particle concentration. We said WPC, wear particle concentration. So, and also measure the size of the wear particles which are there after the filter. Suppose the engine, the machine's specification says that the filter is of 10 micron filter, and you find a particle which is 20 microns or 50 microns or 70 microns after the filter. Very clearly we will come to know that the filter is not doing its job. The filter is damaged because we are able to find 50 microns and 70 microns particle even after the filter. That is one way. The other thing is wear particle concentration. It doesn't have any units, but we try to measure. There is a instrument which can measure the wear particle concentration. I'll be showing those things in the coming slides. So the wear particle concentration will tell us after the filter, that when we take the oil sample after the filter, it will tell that how much is the wear particle concentration. Before the filter also we take, then we can know the health of the filter in the machine. The other one is the wear particle concentration for a particular type of turbine or for a particular type of transformer or a motor or a generator or a alternator, whatever equipment it is. If you can take the wear particle concentration before the filter, we have a data that similar equipment in the world with similar environmental conditions and for similar manufacturing, what was the wear particle concentration for normal, for marginal wear and tear, for critical wear and tear. See, there are three classifications which we do: normal, marginal, critical. Normal means like traffic signal green. It shows green light in our equipment. When it is marginal wear particle concentration, it shows yellow color. That means it is going to get damaged anytime. When it comes to red, we have to be very, very alert, and it is very critical and very important. So normal, marginal, critical, these are the three classifications for the wear particle concentration value for each of the engine, each of the machine, what we have the database. So this database is built up over the years, more than 50 to 60 years. This database is available with a company called Predict Technologies, Cleveland. So they have a tie-up with Predict Technologies India Private Limited in Amirpet. So later on it is shifted to Kukatpalli now. So I used to work in that particular company as a machine analyst, and I used to measure and decide based on the quantification, wear particle concentration, that whether the machine is in green zone, yellow zone, or whether it is in what is called that red zone. So the other things are, I will take up the chat questions once the total presentation is over. So let me go ahead. I have not seen the chart, but anyway, okay, not much questions are there. Okay, the next thing what we see is here you can see in mechanical equipment, what are the different predictive maintenance systems. Just now I was speaking about oil analysis, then time domain reflectometry, vibration analysis, proximity probes, tribology monitoring, then performance trending. Now you see oil analysis, I was just now telling how much contamination is there, how much wear particles are there. There are equipment. I will show those equipments in the coming slides, that how the oil analysis is done, how the predictive maintenance systems are working. And and we can optimize the lubrication system. See, some of the equipment, they have 4,000 or 5,000 liters of tank capacity lubricants, and we all are aware of our bicycle. Even in bicycle, there is an axle which is connected to pedals. While we pedal the bicycle also, the axle broke many times. Even two-wheelers, four-wheelers, we have axles. So this is due to the vibrations which come. When we go into what is called a ditch on a road, there is a shocks which are applied on these axles, and the machine fails. You can see that's why we use shock absorbers in the car or in the vehicles also. I'm taking the example of car and scooters because we all use them. So shock absorbers will absorb the shocks. So once the shocks are very high, vibration starts. When vibrations are very high, the equipment fails. So before the vibrations comes, at the level of shock pulses only, we can measure the shock pulses by using sensors. Those sensors are transducers, piezoelectric transducers, which we use in the industry. So after measuring those shock pulses, we can come to know the units are so many shocks per millimeter, so many shocks per micrometer. So that helps us to decide whether it is in red line, yellow line, or green line. Thereby, what happens is we can analyze the condition of the machine. So here, once we analyze the condition, vibrations, we can take the corrective action. So for proximity probes, we use these proximity probes to monitor the gap or distance between the rotating equipment, such as shafts and bearings. So I will talk about the predictive maintenance more as I proceed further into the details of the different wear and tear. See, the lubrication is generally used for two purposes. One purpose is to avoid the friction or decrease the friction between two materials which are touching each other. The other one is to remove the heat developed while the machine is working. So these are the two reasons for using the lubrication in any engine. So we take the engine sample and go for the predictive analysis. So the next slide, let us see some of the products in the market what I am involved in manufacturing. So you can see here, this is a very interesting thing. This is just like a thermometer, This is called motor checker. It can check the health of the transformer, health of the what is called alternator, any three-phase alternator, three-phase machine like generator, motor, alternator or transformer. Here you can see I am showing with the cursor, there are two sockets with resistance and inductance. And these two leads, from these we take two probes and connect to the three-phase machine. The three-phase machine may be motor or generator. We put off the power supply, 230 volts power supply. Otherwise, this motor checker gets burnt out. So we put off and for hardly half a minute or 2 minutes and measure the resistance and inductance values using this analog scale, 0 to 100. So very, very accurately we can measure the what is called that this values even up to 0.001 ohms, 0.001 ohms, and even 0.01 millihenries. So any three-phase machine should be perfectly balanced. That is, if it is in star mode or delta mode, whatever mode it is, Ry, what is the resistance? And YB, BR, we measure three values, and on all the three coils, the resistance and inductance should be more or less same. Then we say it is balanced. If it is not same, if there is a variation, then the coil is getting burnt, coil is getting degraded. That is what we conclude. Again, impedance is nothing but, this is nothing but impedance matching we are doing between Ry, Yb and Br, the three coils, three-phase coils. If the impedance is same, then we say the coils are very healthy. Now, this impedance is made up of resistance, inductance and capacitance. Capacitance effect is very negligible. So in the industry, we measure this resistance and inductance using these two coils and probes. By pressing this red button and selecting the proper range, see we proper range based on the equipment, we can measure, take the range, we can select the range and measure the values. So the impedance, if it is perfectly balanced, we say coils are good. The other one is from the coil to the body, from the coil to the body of the machine, that is generator or motor, we measure the impedance. That is called insulation resistance. We measure the resistance, that is called insulation resistance. We use these two sockets for that. 500 volts DC is generated by this instrument motor checker, and 500 volts is applied between the DC is applied between the each of the what is called coil and the body, and we measure. It comes in mega ohms. Can you see the blue scale which is there down? This blue scale is not uniform, and you can see it measures 20 mega ohms. It acts just like a mega. 20 mega ohms insulation resistance can be measured. More than that, it shows infinity. You can see here M and ohms, mega ohms. So this instrument, electric motor checker, is used in any process industry where there are motors, transformers, generators, alternators, transformer. And in the Navy, Indian Navy, we gave 200 such equipment. This is a thermometer for an engineer to measure the impedance and to know the faults in the machine. One more very, very good advantage of this motor checker is we can know the rotor cage bar cracks. In the rotor, the rotating part, rotor, there may be cracks sometimes develop. That crack can be identified by using this inductance value while we are measuring. The rotor is rotated physically by us 10 degree, 20 degree, 30 degree, and 360 degrees. Total 36 steps, 10 degree, 20 degree, and so on up to 360 degrees. And wherever, if there is a crack, there is a sudden shoot in the inductance value. The meter will shoot up values. Suddenly it will shoot. That means there is a crack in the rotor. Then we stop the checking and go into open the machine and try to change the rotor. So rotor defects, insulation defects, then insulation defects between the coils, then the health of the condition of the motor generator or transformer, any three-phase machine we can do with this machine, with this equipment. And the cost of this equipment is hardly 20,000 rupees. This thermometer of a doctor, like this motor checker for an engineer, acts as a thermometer and for an engineer, and we can buy it for 20,000 rupees. So this is a very good equipment. And apart from this, okay, somebody is asking for full screen show. I will show it, try to show full screen. Okay. Okay, I'm not able to do it. Fine. I will share these PPTs to the concerned people. You can take and you can see this. And I will also give the website where you can get this. So this is for motors, electric motors, transformers, motors, generators, alternators, and all. In the shipping industry, in the Navy also, we supplied, all ships will be having this equipment. They use this equipment for finding the health of the motors and generators which are used in ships, big ships. So in Visakhapatnam, we have supplied 200 such 200 equipment, 200 motor checkers for the Indian Navy. Now, the next slide, which talks about, one second. Next slide is the bearing checker. So the bearing condition is found out by using these headphones and using this measure M value. Can you see here green, yellow, and red? Green, yellow, and red. There are colors here also on the display. You can see green, yellow, and red. This will indicate, this will tell the condition of the shock pulse. Checking the shock pulses which come before the vibrations, it can give the readings and health of the equipment. So this particular model is very, very useful in the industry. They use, there are 3 models you can see here, different names are there, here another 3. So different models cost different things for different applications. We use this bearing checker. So let me go to the next slide. Here, this is another vibration tester. After the shock pulses have come up, vibrations come, that time you can use this. Here also you can see MCM, machine condition monitoring instruments, MCM instruments, Miapur. So this is the industry which I developed in the initial 2 years and then left it to the promoters. You can see the vibrations meter, VIP33, it measures the vibrations, and based on the database, we can tell whether the machine is in good condition. That is, green condition is good, yellow is deteriorated, red is damaged. So the next slide will speak about the transducer. This is a transducer, the transducer means it is a stethoscope for the doctor. As stethoscope is there, this transducer is going to pick up the signals, electrical signals of the non-electrical is converted to electrical signals by this transducer, and the electrical signals are fed to the instruments what I have shown, and thereby it can predict. So now let me go into the correct subject. This is the ferrography technique, Predict Technologies, Cleveland, USA, who have brought the equipment in 1995 to Amirpet in Hyderabad. And this was the first company. Predict Technologies India Private Limited is also there from those days. So here you can see this is the ferroscope. This is the ferroscope what I told, which is used to measure. It is 100x, 500x and 1000x. This eyepiece is having values. We make the blood slide, just like the blood slide is made on a glass slide, you put the blood and take the sample of the blood and try to find out the ferrous particles. That is, whether it is low alloy steel, medium alloy steel, or case hardened steel. See, case hardened steel will look something like case hardened steel will look something like this purple color, Can you see here this purple color? This is case hardened steel. So this particle has come from the gearbox. If you see this yellow color, they have come from bearings. This is a medium alloy steel. Can you see this ferrous particle cutting? This is called cutting wear. You can see this is something like the, what is that called? Lathe machine turnings which have come out. So the gear wear, this is the gear wear. This is the bearing wear. This is the case hardened steel coming out from gear. And if you see this type of blue color, sky blue color, it is from the shaft of the machine. Shaft rotates, shaft rotates. The rotating part has worn out. So I was one of the analysts like this who was using this ferrogram under these ferrous particles, and I used to measure the size of the microns. Suppose wear particle, size of the wear particle. You can see here, this is going to measure the wear particle concentration. This instrument measures WPC, wear particle concentration. It tells the what type of wear it is, severity, how much it is, which component it has come out from, what is the cause of this machine wear, whether it is from gears, bearings, or the shaft. And we can quantify it by using wear particle concentration machine. This is the WPC machine. This is the ferrogram, what we are making. Ferrogram means it is a slide, just like our blood smear, they put it below the ferroscope and they measure. That is how they do that. And finally, we write a report in the next slide. This is a report. This is a report where you can see red means critical. If it is yellow, then it is marginal. If it is green, it is what is called okay. It is normal, marginal, critical. These are the three ratings we give overall machine, and we give the recommendation. We also give the results. How much wear particle concentration is there? And as I told, the company name is Predict Technologies Cleveland, USA. And in India, by chance, we are in Hyderabad, and Hyderabad is having this company called Predict Technologies. We give this report. This is the first part of the report where we give the recommendations. This is a sample ID, just like blood sample ID also we give. Name of the component is bearing, lubricant, how much it is, all details we give here, which date it is, sample is collected, when the report was made, what is the recommendation. Recommendation means changing the oil may be a recommendation, changing the filter may be a recommendation, or the recommendation may be that another 6 months, this particular machine may not work. And we discuss the results, all these results. All this is done by using AI. In my times, we used to have the server in our company, but now cloud computing, quantum computing has come up. That is the only difference. Otherwise, the same technique is used. You can see the results here. What are the different types of wear particles we are seeing? Cutting wear particle, severe sliding wear particle. Sliding means one material sliding over the other. Then normal rubbing, normally it has rubbed, normal rubbing wear, 0 to 10 scale, we give the rating. See, if anybody gives you a particular quantity of, suppose, peanuts, you just take it in your hand and measure. You can say whether it is 100 grams, whether it is 150 grams or 200 grams. But no, a 200 grams quantity, nobody will say it is 1 kg, right? Same way, based on the memory what we have, based on the intelligence what we have, we can measure, we can quantify the wear and tear of the machine in the oil which is there by making these slides. And here you can see the trend also is given, percentage of large wear particles we have given the y-axis, x-axis the different dates and trending. This trend will tell us when the machine may fail. So ferrogram, this ferroscope, making a ferrogram and analyzing the ferrogram. These are the three stages for doing this ferrography technique. For finding out the type of the wear particle in the oil, severity of oil problem, severity of the problem, then what are the components they are getting damaged. I want to share one thing. I was in L&T cement plant in Awarpur Cement Works, where there is a bearing which is size of 10 by 10 room. 10 by 10 room, whatever size is there, 10 feet into 10 feet room, that size bearing, it costs 4 crores. From Germany, they have to import. Suppose they are using this ferrography and technology, ferrography technology, they can get the bearing just before 2-3 months before, and they can keep the stock. If they keep the stock for 1 year, 4 crores interest, you can see how much money is lost there. So now time is running short. So these are the various types of technologies, like preventive technology I told, time-based technology I told, predictive technology I told in detail. The equipments what we are using, you can see this is the different equipments what we are using. In the industry, we use these equipment for measuring vibrations and shock pulses. So based on the color, color of the particle, we can tell that from where it has come. So this ferrogram is heated for 70 degrees temperature, and then we can get these colors based because of the structure of that particular components. This is from bearing. This is from the bearing. This is from the gears, and these particles are from the gears, cutting wear. These are the normal rubbing wear. So different types of wear particles I have discussed.